So welcome everyone. I'm Richie with the University of Georgia's Center for Urban Agriculture. The center supports this webinar technology for UGA extension and would like to introduce you to the host of this webinar series. Dr. Shimat Joseph is an assistant professor of entomology in the Department of Entomology at the University of Georgia. He's located on the UGA Griffin campus. Dr. Joseph's research area is turfgrass and ornamental pests. Shimat would like to welcome you and introduce you to our first speaker.
Thank you so much, Richie. Welcome everyone. Dr. Jim Kerns is our first speaker. Dr. Kerns is an associate professor and extension specialist in the Department of Plant Pathology at North Carolina State University. Prior to starting at NC State, in December 2012, Dr. Kerns was a turfgrass pathologist at the University of Wisconsin-Madison. He earned his bachelor's in agronomy from North Carolina State University, master's in soil and crop sciences from Texas A&M University, and a PhD in plant pathology from North Carolina State University. Dr. Kerns' extension efforts focus on educating turfgrass managers on disease identification, employing control measures that are efficacious, cost-effective, and environmentally sound, and fungicide resistance management. His research while at University of Wisconsin-Madison focused on three important diseases of turfgrasses in Wisconsin: dollar spot, anthracnose, and snow mold. At NC State, Dr. Kerns' research program will focus on summer stress management of creeping bentgrass, etiology and management of ultra-dwarf Bermuda grass diseases, fungicide movement in clippings and soil, disease management in tall fescue, and nematode biology and management. Welcome, Jim. The floor is yours.
Thank you, Shimat. Thank you, everybody. It's a real pleasure to be with you this morning. Talk about something that we've been working on a fair bit here at NC State, nematode biology and management. And then, of course, with this time of year, of anybody who's working in the landscape, you got to throw in a little tall fescue for good measure. So without further ado, as we move through this, okay. So just thought this was a good idea to go through a really quick history of nematodes and turf. And for a number of years, nobody cared. We have Nemacure, right? So we had some products that old organophosphates and carbamates, whether they were nematicides or insecticides, that really controlled nematodes and kept them at bay. Then people started freaking out because Nemacure is going away. What do we do now? And then at least for big commercial properties, golf courses, athletic fields, things like that, they said, once again, who cares? We have curfew. A curfew is interesting because it had to be knifed into the turf. It could not actually be applied to the turf because it was actually toxic to the turf. And then some research was going on with that and said, well, you know, maybe this isn't the answer. We need something else to kill nematodes. And after coming back to NC State in 2012, this was the first question I got, and then more, you know, how do we kill these things? And then now we have several things that can kill nematodes, but how do we actually use them? And I think one of the biggest points of this, as we're going to go through biology and go to management, is we really need to shift our focus from killing them to managing them. Because in truth, even with Nemacure, we didn't really kill them as well as we thought. So what are nematodes? And I think this is always important to understand, what are we dealing with here? So this is very unique compared to other plant pathogens because this is an animal. It's, you know, more closely related to an insect than it is the other things I study, like a fungus or a bacteria. So the animals belong to a phylum called Nematoda. They're unsegmented roundworms, right? They're microscopic for the most part. They molt just like insects, and they have a tubular digestive system. Now, one of the most interesting things is if we had the ability to have people raise their hands, anytime I'm speaking to a group, I ask, how many people have nematodes? And I say everybody should raise their hand because they're the most plentiful animals on Earth. As a group, they're adapted to nearly every habitat of the ecosystem. And it's interesting that only 25,000 species have been described, and yet there's estimated to be 1 million or more in total. Roughly half of those are parasitic to something. That doesn't mean plants. Nematodes are animal parasites as well. There's some really nasty animal parasites. If those of you who like to look at stuff like that on Google, there's really disgusting photos of nematodes and eyeballs and legs and things like that. And then half are free living. Any sample that comes into our lab that we're doing a turf diagnosis with, you can see free living nematodes. They're constantly swimming around in turf systems. And it's estimated they account for about 80% of all the animal individuals on Earth. And just to give you an idea, those of you who may like to drink beer, the next time you're sitting there and you have, at least in Europe, they call what we call a coaster, they call a mat, that there's a nematode that lives in that beer mat or in that beer coaster, right? And just shows you, I think, how widely and readily adaptable these organisms are. I thought it was pretty interesting with this is if you look, they call it either the beer mat or sour paste. It has also been isolated from rotten peaches and bookbinding paste. I don't know how any of those are related to one another, but I think it gives you an idea of how prevalent nematodes can be. The other one I like to use is those of you who like going to the beach. If all the sand was washed away, there'd be a 2-foot layer of nematodes there. They're marine. They live in water, and I think that's another important thing about nematodes. Now, as far as those that affect plants, they have a very specific morphology associated with them. That morphology is very simple in this case. I think you can see this up here in the upper right is what we call a stylet. Basically, what that stylet is a hypodermic needle that's in their face, and they have the ability to puncture plant roots and suck out those juices that they might be feeding on. So what do plant parasitic nematodes do to turf grasses? I think the first bullet point here is pretty important. So nematodes are obligate parasites. So what does this mean? It means they cannot grow and reproduce without a living host. So nematodes, they rarely kill the turf outright, but it can increase its susceptibility to abiotic stresses and other pests. So that's interesting as you look at some of these photos because the symptoms are very non-discrete. It's not like brown patch or other diseases you may be familiar with. It basically, you know, the density is reduced, the growth seems reduced. One of the biggest things you can see is the turf wilts or dries out much faster, even under conditions where you wouldn't anticipate that. So, and then if you pull out some plants, or you're able to pull out a plug of turf, the below ground symptoms, you'll see pretty stunted roots, right? In some cases, the roots may be deformed. Some nematodes, they produce what's called a hawk's bill root. So it looks like a hawk's bill, kind of crooked and pointing down. And then many times we see necrotic roots associated with it. So the other lovely thing about nematodes with turf is there are a bunch of them. There's a bunch of plant parasitic ones. So this was some work that was done here at NC State, where they looked at the different genera of parasitic nematodes associated with turf. So they had a huge sampling throughout North Carolina and South Carolina, and basically characterized the parasitic nematodes in turfgrass systems. Most of these were golf course putting greens, but along the coasts in sandier soils or loamy soils, a number of these were collected from home lawns as well. So you see the diversity here. It's really staggering the amount of plant parasitic nematodes that can exist in a turf system. And what we're going to go over today is at least the ones that tend to be most problematic. So how do we classify these nematodes? They're named basically based on the type of symptom induced or some unique physical characteristic, right? So you have sting nematode right here. It's called sting nematode because it's a big nematode and it has a great big stylet. So you could think of it almost like a wasp or a hornet of the nematode world. I mean, it is very, very destructive. Then you get a lesion nematode. In this case, this little nematode swims inside of the roots and creates a lesion in the root. Lance is another great big nematode, so it has a lance-like stylet. And then the one you see here, ring nematode, gets its name because of these kind of annulations that go across, or rings that go across its body. And then a number of other ones here, and a few of them we will talk about as we go through this. So this was the prevalence from turfgrass from that particular survey that we did. And you'll notice it's highly variable. Look at ring nematode here. The average population level across, I can't even remember how many locations, it had to be 1,000 or 2,000, was 226 plus or minus 659. So highly variable, and that's a very important aspect of nematodes and nematode detection, is they can be extremely variable and change populations in short spatial areas. So if you look, it ranged from 10 to 8,200 ring nematodes at that place that they sampled. And you can see this as you go through. You see the ones that are really prevalent, ring and spiral. They're in almost every turf sample that I have seen with that is sent off for nematode analysis. The thresholds for these are extraordinarily high for turf. Now, that being said, that depends on the crop. Ring nematode is associated with peach short life disease. So, and that's another big thing that I think people have troubles with these organisms, is that just because they're not a problem in turf doesn't mean they're not a problem in something else. Spiral nematode, it's constantly there. It is undoubtedly a stress, but is it something that's worth managing? Because at least in my experience for these two in turf, you can adjust management practices such as supplemental nitrogen, supplemental irrigation, without the need to deploy a chemical. Now, a few on this list that it doesn't work that way: root knot, stubby root, sting, lance. those tend to be about the big four for us in the Southeast. Root knot has primarily only been a problem in very fine amenity turfgrass. So these would be things mowed really closer to putting green height, where we've seen root knot nematode be most problematic. So anybody not at a putting green, the big three tend to be stubby root, sting, and lance in this particular case. So just showing you a different representation of this, and those of you who may want to go back and look, there was a nice publication of all of this work in Carolina's Green, and I'm pretty sure you can probably find it on the internet if you go out and search, but just shows you the prevalence as far as the number of locations. Once again, ring and spiral, very prominent. You see a lot of root knot and stubby root out there, and then in the Southeast, unfortunately, we see a lot of sting nematode. And sting nematode is by far the most destructive nematode pest in turf. So this is always a really good question that I tend to get going around the country to speak. How did they get there? How did nematodes get in my turf? Well, they can move in from surrounding soils. So let's imagine a home lawn or golf course. They do a renovation, but they only renovated a portion of it. Those surrounding soils, they can move in from there. They can come in on planting material. So they can come in on sod or sprigs in athletic fields and golf courses that are top dressing with sand. They can come in that way. They can be brought in on cultivation equipment. If you see down here on this particular picture, really all it can take is, a few eggs in there, and if they get established, then they can be problematic. And although we focused on soil fumigation for a long time, it's just a temporary fix. Nematodes are likely to come back in, be reintroduced over time through various means, and that's one of the big issues with a turfgrass system is we don't have the ability to fumigate every year. So eventually they're going to get back in. And then on top of all of this, remember, they're the most abundant animals on the planet, right? It's very likely that they're going to get into a system. The difference is, are they problematic? So I thought this was pretty interesting, and I apologize, it's just a little bit fuzzy on here. I think I must have not taken the best image from the manuscript, but you see nematode prevalence by soil type in North and South Carolina. So look at something like sting. One of the things you'll see with nematodes is the bigger they are, the harder it is for them to survive in a clay or loamy soil. So you see most of what we see as sting nematode is in sand, some in loamy. Now look at ring root knot, right? They seem to predominate in every soil type, even root knot here in clay soils. So we can see root knot nematode in areas of the country that we never anticipated. And this is actually indeed becoming, or is an emerging problem, in my opinion, throughout the U.S. Not so much in the landscape as of yet, but definitely in golf courses. You see another great big nematode here of lance, really can't survive well outside of sand. Now stubby root, this is one we'll talk about a little bit later that we have found to be quite problematic in zoysia grass landscapes, especially in sandy or loamy soils. Can survive in a lot of different soils. So just giving you an idea of where we see these things. So how do we diagnose nematode problems? One of the key things is looking at those field symptoms. So what are the patterns of symptoms in the turf stand? And typically with nematodes, it can be very irregular. You're not going to see a patch in most cases, unless those of you may be managing a golf course or athletic field. But in higher heights of cut, you usually just see essentially like this right here. You see it just One of my favorite descriptions, if you read the literature, is unthrifty turf. I don't really know what that means, but I like it. I think it's pretty funny. So the other big one when I'm talking to people is when they've, you know what, Jim, I think our fertility's good, soil moisture has been good, and it's just not responding. I think that's a really good indication that you may want to check for nematodes, because that's what these things do. They're feeding on the roots, they're disrupting the root activity, so it doesn't allow the plant to take up fertilizer and water. Other things that you may notice is the depth of the root system may be impaired. I'll show you an image of that a little later. And then the color. It can be very necrotic, very brownish kind of color. Or if you see a distinct stunt of the roots. And then, of course, if you see any kind of galls or knots on the roots, that's a very good sign of root knot nematode. But again, at least for now, that seems to be most prevalent in lower heights of cut, and in particular, putting greens. What the soil texture is, all nematode problems are going to be more severe in sandier or loamy soils that are prone to drought, right? Have less nutrient holding capacities, things like that. Is there any recent history there, recent nematicide applications? And one of the things that I think some people have a little issue with, if you're going to send off for nematode samples, and I know each university, whether it's Georgia, Florida, South Carolina, North Carolina, they have separate nematology labs because the actual analysis is different than doing a disease analysis. So why that is the nematode analysis actually is collecting the soil, right? Filtering the soil out and basically selectively harvesting the nematodes for counting. And disease diagnosis, we wash a lot of the soil away so we can have a good look at the roots. So in both, if you suspect nematodes, what I tell people is you should submit a nematode sample to whatever lab or whatever state you're in. Most states have very good disease and nematode labs. And then also submit one to the diagnostic lab just to make sure that it isn't another disease. So this is, great question. Were nematodes part of the problem? Well, this was taken out of some work that we did years ago looking at, here's nematode or an area of turf. This is actually Bermuda grass that's treated with a nematicide versus untreated. So I'll let you make the decision. Were nematodes part of the problem? And indeed, they were. This is distinct stunting in here, almost no rooting below this particular layer. And this is indicative of sting nematode. Such a big nematode, big stylet, that it really destroys the root system readily. So some other symptoms, we've already kind of alluded to these: reduced tolerance to abiotic stress, reduced root growth. And this is one that I think is very interesting, is that we see increased susceptibility to diseases. So like take-all root rot in St. Augustine grass, or summer patch in Kentucky bluegrass, Pythium root rot as we get into lower heights of cut. And I think this makes sense if you understand the nematode has a stylet. It pokes the stylet into the root, basically opens a wound, and then these fungi go in right behind it. Some really interesting work was done by Billy Crow at Florida that to demonstrate this, that they took a non-pathogenic Pythium species, and in the presence of sting nematode, it became a pretty aggressive pathogen. So in other words, the organism, the Pythium species, must not have been able to breach the root, but with a wound, right, with that nematode there, it must have been able to get in and cause damage. So that's why, with nematodes, I think nematodes are going to be one of the biggest issues in turf moving forward, because of something like this, that they can be sitting there feeding and make us more prone to other diseases. As I mentioned, they can be irregular, as you see here. This is very typical in higher heights of cut. This happens to be a tall fescue, Kentucky bluegrass mix for sod, just yellowing, and yet it's well fertilized. And as I mentioned, the only time we see distinct patches is typically at lower heights of cut. So this is a golf course putting green, and you'll see these distinct patches. I have not seen that yet in higher heights of cut, but I don't ever rule anything out because things seem to always change. So in Bermuda grass, so this is a golf course fairway, but this would be analogous to an athletic field, home lawn, where we see the damage. Once again, you see it on a slope, drying out. You know, really looking at that as a homeowner, a turf manager, you'd go, well, it's probably just dry. And if you would to water this, it really doesn't bounce back that much. And indeed, this particular location has a issue with sting nematode. So as I mentioned about what the roots look like, if you look down here in the bottom left, you see that these roots are stunted. This is that little hawk's bill that we see, right? This is the root tip that's kind of curling, and it responds to the feeding. You notice how this swells up. This isn't root knot nematode. And these are the things that we can see even in a diagnostic lab, that as they come in, we may say, hey, you know, you may want to check for nematodes because it kind of looked like nematode feeding in the roots. And then over here on the right, you'll notice these darkened areas all through here. This is where another fungus has moved in behind the nematode and degrades those roots even more. And the complicating thing here is you have to manage both. If you don't take the fungus out, the roots won't heal. And if you don't take the nematode out, you're never going to really control this fungus. So you can see where they can be a challenge. Now, one thing that's really important is one of the first principles of plant pathology is we have to understand what a healthy plant looks like. And those of you who may be just getting into the business, it's important to keep in mind that some of our turfgrass roots are not bright white all the time. This is a good, healthy Bermuda grass root system. You'll notice it's kind of dark, kind of brown. And I say this because people that come from up north to the southeast, they're used to, you know, vibrant, bright roots in perennial ryegrass or tall fescue. Although Kentucky bluegrass doesn't really have real bright white roots, so it could kind of freak them out to see something like this. But that's amazing in most cases. So how do we collect a nematode sample? They're obligate parasites, so you have to collect to the depth of the root system. And I'll show you a little bit of the work that we've done, but it's 6 inches for sting nematode, and that's what we just recommend for everything, especially in a landscape, because your roots are going to be 4 to 6 inches anyway. Don't sample any dead or severely damaged areas, and at least for NC State, what our lab does, and they also do out-of-state samples. Those of you who may want to use them, is we collect 15 to 20 cores to the desired depth using a 1/2-inch soil probe. And I think this is important, that remember, they're highly variable. So a single point sample may not be enough. And this is key, these last 3. If you're going to send off a sample, remember they're marine. So if that soil dries out, they're dead. They won't be able to count them. And if it gets too hot, they will cook. And I know this from experience and research. That we just had a trial in the greenhouse where it got too hot and all the nematodes cooked. So if you're going to do this, collect the cores, put them in a plastic bucket, and immediately transfer them to a plastic bag to retain the moisture, and then get them into a refrigerator if you can't get them to a nematode lab right away. Don't let them heat up, and don't let them dry out for the best analyses. So as far as sampling, I think this is pretty self-explanatory. Preventative, if you just want to know then you basically just do a zigzag across the area. And one of the things I'm going to talk to you about just shortly is you may want to section off areas. So in other words, don't sample the entire home lawn or athletic field. You may want to section it into smaller areas because they're so highly variable, and I'll show you that in a minute. Now, if you already have samples, so if you imagine that image I showed you of the tall fescue that was struggling, right, you would want to kind of skirt the damage. As you notice, this is moderate damage here and along the edge. If you go in here where it's yellow or dead, then you're just going to miss the nematodes because they can't live without the host. So this was some work that we did down at the coast of North Carolina, and all it is we have to pre-sample everything. These are 3 by 6 foot plots, so 3 feet by 6 feet, right? And these are different treatments that are going out, replication, and it shows you that, look at, you can, from 3 feet away, right, you can go from 290 sting nematodes, which is exceptionally damaging, to 37, which is, you know, moderate, to then another 6 feet to 11, and you're, you know, kind of at the threshold. Whereas look at over here, you could have none. So I think it really illustrates how variable nematodes can be. And if you imagine, if you did a sampling scheme through here, this large, you could really dilute the number of nematodes. It may give you a false negative of what you should be doing, right? And you notice it can change over time, is what the bottom one is showing. This is one from an athletic field. I think it's a great thing. The way we went out and sampled for them, we sectioned the athletic field into what, 20 different or 19 different sections. And it gives you a really good indication of where the pressure is. And I would suggest this for anybody, whether it's a home lawn, athletic field, golf course, because it just gives you a much better idea. And for the most part, nematode samples are not all that expensive either. So nematodes have different feeding habits. Basically, they feed outside of the root or inside of the root is what this says. And some of them don't move. Once they set up a feeding relationship, they're sedentary, and some do move. And that's important as far as management. We really can only manage nematodes when they're outside of the roots. And I think that's an important thing to keep in mind as we go through this. Sting nematode, I've already mentioned, really destructive nematode. Their populations vary through the year, and essentially what this is telling you is this is on Bermuda grass, so a warm season turf. They start to become most active, you know, about May through June, you know, into July, and this is the target right in here as far as managing these. Showing you as it relates to temperature here on this particular figure. This is interesting because you'll notice that the vast majority of nematodes that are near the surface, so 0 to 15 centimeters is, you know, about 4 inches. Well, I guess more like 6, but anyway, you see that we have nematodes near the surface in the spring. This is important because it is exceptionally difficult to move products through a turfgrass system. So if we're starting to target them when we see the damage in July, you'll notice that they've started to migrate deeper into the soil. So it can be really hard to effectively manage them at that time. At least also notice that in November, December, they start coming back up to the surface. So there's some things that we're still working out with nematodes. We did this work ourselves, basically showing you a more repeat here of these two nematodes, but we basically went out and sampled a bunch of different courses in the state. We sectioned the core into 4-inch segments and counted root and sting nematodes. So basically showing you here, right, where are they in the profile. And I had my PhD student, Glenn Gully, did this particular work. And you're going to see graphs that look like this, and they're busy, but I'm going to summarize it very, very easily for you in that the gray bar is when they're near the surface, the top 4 inches. So you see where they are, right? April, May, June. As we start to get into July, they migrate deeper because it's too hot for them. They have to get down into deeper into the soil, or they're gonna cook. So see this for Bermuda grass. We also did it for a cool season turf, creeping bent grass in this case. Oops. I'm sorry, I keep hitting the wrong thing here. You'll see the same thing, that they're more near the surface early in the year, right? Versus in the summer, most of them are way down deep. So quick little summary, well, I'm sorry, root knot nematode, those of you who may have any finer turf, it never leaves the top 4 inches of the soil because it actually establishes a very specific feeding relationship with the host. So it's not going to migrate down like sting nematode does. And even though we know that sting nematode migrates down, we don't really know what it's doing and how it can do it, which is something we hope to answer here soon. So to summarize this, as far as sting nematode, and we don't know this for the other nematodes, we have focused on sting because it's been most problematic in the southeast. They start to increase in the spring. They don't decrease significantly until late fall. The populations are much deeper in the summer months, so it's hard to get them with our nematicides. And more importantly, most people recommend a 4-inch depth. So we may be missing them if we're sampling during the summer months. Whereas root knot, they start to increase in the spring, they drop in the fall. We only found what's called stage 2 juveniles. So they're the ones swimming in and feeding on the roots, and they remain up near the surface. So we have some ability to manage them. Showing you symptoms here of root knot. I think, what is this, in soybeans? Just a bigger image. I know it's not turf. This is what they look like in a turf root. They're sedentary, so they basically the female buries her head in these cells here and then becomes an egg-laying machine. So you can see where they can be problematic if they're feeding on the material coming down to the roots. Just a generalized life cycle for your information. And so what does this mean as far as management? And I think, although this work is a little dated from Lori Trenholm in Florida, I think it's very interesting work in that if you look at your control, and this is the amount of wilt that occurs over here on the y-axis, you'll notice if we manage the nematodes, this was Nemacure and this is Curfew, notice how the amount of wilt can substantially decrease. So indeed, that managing the nematode helps you manage that turf a little better, makes it tolerate those abiotic stresses. Now, I mentioned this was one that we found during that survey, basically a stubby root nematode in North Carolina. We found it from Bermuda grass, St. Augustine, and zoysia grass. These were actually collected from a golf course in Wilmington, but we have since documented this from home lawns down around the coastal area. It's another big nematode, so it's going to be primarily sandy soils, but this is a real limiting factor we found for zoysia grass adoption in our sandier soils, that this can be a very aggressive nematode towards that particular turf. So something to keep in mind for those of you out there. Some of the nematicides I'll show you seem to work pretty well on this organism. So what do we have out there? So essentially we have a few products on the market that are labeled for every aspect of the turf industry. It used to be called Avid. It is now called Divinem. I have an updated slide of this, but this is abamectin, very strong nematicide. Some of you may be familiar with the derivatives like ivermectin, things we may give to dogs for heartworms. And then this particular product called Indemnify, which is actually a fungicide. The active ingredient is fluopyram, and it is an exceptional nematicide in the work that we have done. Now, one word of caution about the nematicides, and this is not my doing, so you can take it up with distributors and chemical manufacturers, but Divinem and Indemnify are expensive. And Indemnify is very expensive. I think $1,650 an acre. So it may not even be feasible, but anybody with a high-end commercial property, it seems to work pretty well. Now, what we have found is we don't see nematode counts declining with the Divinem product, or the older name was Avid. But I'll show you something with this a little bit later. With the Indemnify, however, notice we actually reduced the nematode counts very well. But more importantly, we could do it with lower rates. So at least it can cut the cost in half, because the $1,650 an acre is the high rate here. The other thing I think you'll notice is if we target it early, you know, look at how good a control we got with just a single application, okay? So I think that's promising, albeit they tend to be expensive. Just to give you an example, this was a totally different trial on a golf course putting green. This is untreated. This is treated with Indemnify. So look at how much better that turf is. Is it 100%? No, but it is remarkably better. This is just a single application of that Indemnify product. So now this switches. This is not nematode populations. This is turfgrass quality here. So if you'll notice, turfgrass quality for the Indemnify, when we applied it around June in this case, worked really well, right? The other thing here is look at this Divinem product, okay? Worked also very, very well. So again, this is just something to discuss with whomever you may purchase chemicals from. They have been very effective for us as long as we get them out relatively early in the year, so somewhere between April and June. The other big thing with managing these is we water these products in with at least 1/8 to 1/4 of an inch of irrigation. So applying these is not going to be feasible in a situation where they don't have irrigation. That's just the nature of the beast here. So absolutely have to water these in to be effective. And if you'll notice this little product here, this is something that we watered in. Xteris, a different fungicide, also seemed to work quite well. Showing you more data points here that when we actually mixed the Divinem with a fungicide and a wetting agent, it was actually quite exceptional turfgrass quality in this particular case. Now this is actually tailored more for athletic fields and golf course putting greens, but I know of some areas down along our coast that have done things like this in the landscape as well, because nematodes have been their single biggest factor that they're trying to manage. So as I said here, Divinem, Indemnify, very effective. This is the key. Absolutely unequivocally have to be watered in as soon as possible with at least 1/8 of an inch of irrigation. If you can't do that, then try to manage the nematode with supplemental fertility, aerification, and supplemental water with overheads or something if they don't have an irrigation system. So these are just some keys for you. I don't think there's any real need to go over all of this. This is just a brief review. But I think one of the interesting things, again, sampling error is high, right? So nematode counts, they're made for a guide. not necessarily to make decisions on the control or to evaluate nematode performance even. So the populations naturally go through boom and bust cycles. So it can be really hard if you go out, make the application, and you sample afterwards, you could see, well, nothing happened to the nematode. Well, in some cases, what we see with these nematicides is you treat the initial population, you grow more roots, and you can see more nematodes, a month or two later, because the plant is now able to tolerate that nematode feeding. And I think this is one of the big things, right? In nematicide performance and other systems are evaluated based on yield, not the number, right? How does it affect yield? And we don't really have that ability in a turfgrass system, right? So how do we actually evaluate it? And I'd say that it's turfgrass quality. Did the turf respond? Did it get better? Did it respond to the fertilizer? Did it respond to the irrigation? Okay. So just a little bit here, I wanted to give you a little bit of work that we've been doing in tall fescue, essentially focused on nitrogen fertility. And that I know a bunch of areas say don't fertilize tall fescue in the summertime because it promotes brown patch. And we really started thinking about this partly because I have a very good landscape company who takes care of my tall fescue lawn, and I'm pretty sure they fertilize it in the summer, and I've never had brown patch. So we started looking at this more, and it was interesting to me that it was really only 3 publications that documented that, and some of it was up to 7 pounds or 6 pounds of N per year. I don't know too many. I mean, maybe some homeowners are making mistakes and getting that high, but I doubt it, or landscape contractors. So really high amounts of nitrogen in there that promotes brown patch. So we looked at this again because we've also had, if you go back and look at the papers here, they're a little dated. And we have a bunch of new cultivars of tall fescue. And so we looked at this. And basically this brown bar is the amount of disease. The green bar is turf quality. We applied this rate evenly over the course of, let's see, this was May, June, July, and August. So no nitrogen, and it ranged from 1 to 6 pounds of nitrogen. What do you notice? Well, if you know anything about academics, they're always going to have little letters in here, and we don't have little letters. There was no significant difference in the amount of brown patch that developed over a 2-year study in the same location. Now you'll notice turf quality also didn't change. Why? Because they all had brown patch. We didn't treat it with a fungicide. So at least we're getting to the point of these turf type tall fescues that I'm not advocating 6 pounds of N a year, but I think a little supplemental fertility during the summer is probably okay. Now we also looked at application timing, where you see all the different timings here. So whether it was March, September, or we did it once a month, and we targeted 3 or 4 pounds of N per 1,000 per year. Once again, brown bars are disease. What do you notice? No significant differences here. All had brown patch in it because they weren't treated with a fungicide, but none actually promoted or significantly enhanced brown patch in this particular trial. Now, some of the big questions I get is, so I went out and made a fungicide application, and then it rained shortly thereafter. Do I need to go back and reapply? So we simulated rain events in tall fescue where we did an inch basically of irrigation 15 minutes after application. And look at these particular products that are common for brown patch control: Insignia, Fame, Heritage, and then even the granular product. Look at how well they worked. So not highly recommended, but the fact is that these fungicides are designed to stick to the leaves, and as long as they're applied to a fairly dry surface, they stick and probably get inside of the plant fairly readily. Now, I know many of you probably don't know me, but the industry in North Carolina does and knows I can be fairly competitive when somebody challenges me. And one day at a field day, one of our lawn care operators said, well, you know, you guys don't do anything like we do in the field. And then I took that to heart and said, okay, fine. Well, we'll put it to the test. This is how we spray plots in this little, you know, single nozzle setup with CO2 and bottles. Here are our fungicides. Indeed, nobody does this in the real world. We go out, spray it here on plots, in small plots, not very real world like. We also evaluated this unit because this company actually asked, you know, would you put this and evaluate it for us? And the Permagreen company donated the product, and we said sure. So I think you can see barely here the fungicide coming out. The interesting thing with this is the water volume is 11 gallons to the acre. Everything else we spray is 2 gallons to the acre, and the typical hose reel unit's probably, you know, 2 to 3 gallons to the acre. So we would assume the ride-on unit wouldn't have the best coverage. And what do you notice? No differences. Now this is with Heritage at 0.4 ounces. So really it was more about the fungicide. This was done over 2 years. This is still baffles me that we saw this good of control. But all I can say is it was enough to stop the epidemic here. So number of ways I think to apply. The point here is pick the best fungicide. Okay. If you need help with that, I'd advise you to go to one of your local turfgrass extension specialists or turfgrass pathologists. We have different ratings on turf files. If you type in turf files in Google, it comes up. And then also Paul Vincelli at Kentucky publishes a really nice fungicide guide every year where he also will rank efficacy of the fungicides. Just showing you the picture so you know I'm not lying to you here. And then a couple little things. We've seen some good work or interesting results out of an organic. This is not a fungicide. This is like a supplement, I guess, from Harrell's, where it actually somewhat reduced disease by itself and really had a nice quality when associated with a fungicide program. So something to maybe consider. As well as we saw a reduction in disease with a wetting agent. Also, I've often wondered why we don't do more wetting agents, at least in higher end properties, because they have some nice effects. And that's all I wanted to show you here. What I want to leave you with is some people have asked, what about some organic products? And this is a product called Zeo, which is coming out of a company called Ag Biome, which is basically a bacterium in a jug that for us has worked very well for brown patch, as you see here, comparable to the low rate of Heritage. I don't know what it's going to cost. I know the company is still ramping up production, but I think it's very promising that the fact that we have a biological product that actually worked for brown patch, and we're testing this in tall fescue, and it works pretty well this year. I just didn't have a chance to update the slides with some of the newest data. I guess final thing to keep in mind is we're seeing a fair bit of gray leaf spot the past couple years in tall fescue. The products that control brown patch, such as Fame, Insignia, Heritage, aren't quite as strong on the gray leaf spot. Thiophanate methyl, for some reason, seems to be very, very strong for that. So anybody struggling with that, you may want to mix that into your particular mix to show you that it's different from brown patch. These are what the lesions look like. And indeed, this is not something to mess with. So with that, if there are any questions in the chat box, I'd be happy to address those. So thank you again very much for joining, and I'd be happy to answer any questions.
Thanks, Dr. Kern. I think we have quite a bit of time. So if you can, write a few questions you have raised now, this is the time for it. And the meanwhile, I have a question, Dr. Kern.
Yes.
So regarding, you mentioned about making application for nematodes early. That's what you kind of suggested. So I was wondering, is there any threshold developed in terms of management? Is that possible, or do you have any comments on that?
Yeah, so very good question about thresholds. Nematode thresholds vary from lab to lab. So like sting nematode, in Florida, they basically say 1 to 10. Other labs may say above 10. In my experience, I think it's detectable for that particular nematode. And I was debating at putting that in, but it really does get confusing because each lab is different. So at the University of Georgia, the threshold or risk that they list for management may be different. So it really is, I think, important for those out there that want to try to manage these to discuss this with the lab that you send to. What is their threshold? What is their risk for management? Here in North Carolina, the report that we get back, they do that in the report. They basically give you a category of high risk, medium risk, low risk. Low risk would be really no management is warranted. Medium, potentially a chemical application. And then high risk would be a chemical application is recommended. So that's where, unlike with insects, where it seems to be the thresholds are pretty consistent, with nematodes, they're highly variable.
That's great. Thank you. Is there any other questions? Please, if you have any, please type in the chat box. In the meantime, I have another question. This is not related to your presentation, but I'm kind of curious because you indicated that when the grass is infested with nematodes, they're susceptible to disease. But have you seen any association with insect pest infestation with nematode? Anything like that? Have you seen anything like that?
That's a very good question. Down at the coast, one of the things that we see pretty commonly together are nematodes and this nasty insect ground pearl. Other than that, I mean, in some cases, the nematode may help bring out grub damage a little bit better. It may make it more prone to armyworm feeding or things like that, but it does seem like our 1-2 punch down at the coast or in sandier soils, I'll say, because it happens in Fayetteville, North Carolina, is a nematode with ground pearls. I don't know that they're correlated, but it seems like when I see ground pearls in a sample, undoubtedly we also see nematodes. So we haven't really documented that as of yet, but that's just an observation that I've made.
That's great. Thank you.
Hey, Shima, there
sure.
are a few questions.
Sure.
If you click on the little bar that says questions, it'll go ahead and pop those up so you can see them. There's several of them in there.
Second.
And you might want to hit the little, there's a little box with an arrow on that same questions tab. That'll make that bigger so they're easier to read.
Perfect. 1 second.
Sure.
Actually, we have indeed a few questions. So first question is, what was the name of the product for management of gray leaf spot?
The name is thiophanate methyl. So there's a number of trade names out there, but if you go at least to turf files, you'll see that in our profile for gray leaf spot. And I'm sure in whatever state they might be in, if they have some sort of ag chemical manual or whatever, they'll have a list of some of those particular trade names. 3336 is one that comes to mind immediately, but there's a number of generic products out there. So that's thiophanate methyl.
That's great. Another question. What is your opinion on using PPZ fungicide for brown patch in fescue?
Good question. So propiconazole is a decent fungicide for brown patch. The only issue with it is it's only going to provide about 14 days of control. And so whereas it is effective, I think some of our QOI fungicides like Heritage, Insignia, Fame, we routinely see 28 days of control with them. Now, the propiconazole, when you mix it with Heritage, it can be a pretty strong combo for both brown patch and gray leaf spot. So there is that particular aspect. But yeah, PPZ is good, but it's not one of the best ones out there.
Thanks. You have another question. Does overwatering have an effect on nematodes?
Does overwatering have an effect on nematodes? That's a very good question. And as far as symptom development, you probably wouldn't see symptoms if you were overwatering, but nematodes do require water, so it could make it easier for them to feed. And then if you get into a quick dry spell like we are now in North Carolina, you may see the turf decline readily. And this is just a guess here because I don't think we've really looked at that all that much. That's a very good question. I would say you wouldn't see the symptoms, but indeed it may enhance the population some.
Okay, we have another question. When applying a fungicide to fescue, will adding iron to the mix to green up the brown areas would that affect the control of fungicide?
Very good question, and the answer is no. Actually, it's I think I highly suggest it for applicators because it gives you a nice greening effect. Matter of fact, I think most of what happens in tall fescue is a little bit of nitrogen and a little bit of iron mixed in with the fungicide, and that gives you a really nice response. It doesn't affect, to my knowledge, the efficacy of the fungicide.
So there is another question that comes up. I think it's kind of a follow-up question based on one of the answers you were giving, I guess. What about nematodes in centipede? I feel like, do you have any comment on that?
As far as nematodes, anything as far as nutrition is going to help because remember, the plant's root system is impaired. So a supplemental nitrogen, a supplemental iron that is taken up through the foliage, I think can be very helpful to, I hate to use this term, but mask the symptoms. So in other words, it can buy the lawn care operator some time for the management because the nematode applications, if they so choose to do it, can take a little bit of time, 2 to 3 weeks to a month. It's not as immediate as a fungicide. So yes, I like also those supplemental iron applications to help with the symptom management.
So another question about nematodes. Have you seen that in centipede grass?
Very good question. We have seen some issues with centipede grass. That's primarily sting nematode. But I find it very interesting that, you know, some people have said, well, zoysia grass doesn't tolerate sandy soils. And I'm not entirely sure it's sandy soils. I think they're not very tolerant of nematodes. And, you know, we haven't really looked at this. It's something we plan on doing with our breeder here, Susanna Mila Lewis, but we don't see as many issues, believe it or not, with centipede grass and nematodes outside of sting nematode. Sting nematode is really destructive on centipede. So it's there, but I think some of the fungal diseases of centipede tend to be more severe, like a large patch.
That's great. So we still have a couple more minutes. So if you have questions, just type it out right now. I'll wait for like a few more seconds, and if not, then we'll take a break, and we'll reconvene at 9:35. I'll give you a few more seconds.